Hey class, we're back in with section 4.4. We're not doing section 4.3. It uses a lot of technology to create models with the Desmo stuff, and it's fine. You can look through that all you want at your leisure, but I'm not going to spend any time with it. Here in section 4.4, we're talking about factoring, or what I sometimes like to call unfoiling. You remember how to foil things, where it's the first, outers, inners, last. Well, what if you start off with that trinomial? Can you figure out what the factors are? So that's what we're going to do. There's a couple of very quick, easy things to work through. First of all, we always want to see, and this is, you notice this is problem number 2. It's a little bit odd. The book does it in the different order. I like always to see if there's a greatest common factor to undistribute first. If you look at this, is there anything in common between a 4x squared and a 28x? Sure, it looks like there's a 4 that goes into both and an x. So I can factor out the 4x and ask myself, 4x times what gives me 4x squared? That would be x. Minus 4x times what gives you 28x? That would be 7. So we have our idea of undistributing. If I redistributed this back, then I would get the original. What do you see in common with these? Certainly not an x, because this doesn't have one, but there does look like a 9. So this could be 9 times x squared plus x minus 2. So that idea right there of factoring that away. Now let's look at problem number 1 then, which is an ax squared plus bx plus c, our standard form, when a is 1. So in other words, there's just nothing there, right? So if there's nothing there, and there is a negative 1, we can always factor out that negative 1. But all of these right here, we can see what those look like. And this is what you're doing. You're looking for numbers that multiply to be this and do this to be this. Numbers that multiply to be 12 and add to be 8. Or numbers that multiply to be 12 and add to be negative 8. Or numbers that multiply to be 12 and subtract to be 4. Numbers that multiply to be 12 and subtract to be negative 4. Those are the different things we're looking for. And if you kind of treat this as more of a puzzle than a chore, it might be a little bit more enjoyable. But I'm going to set up my 2 sets of parentheses here, x and x. And again, I'm looking for numbers that multiply to be 12 and add to be 8. Couldn't that be 2 and 6? 2 and 6. They've got to be the same sign so that when you FOIL this, you get a positive 12. That same sign is positive. So we have x plus 2 times x plus 6. This one over here, same idea. Numbers that multiply to be 12 and add to be 8. But what kind of 8 is it? They still have to be the same sign to multiply to be a positive 12, but they both need to be negative. X minus 2 times x minus 6. How about numbers that multiply to be 12 and subtract to be 4? Hey, wait, that could still be 2 and 6, right? Except that for them to subtract and further to multiply back together 2 times 6 to be a negative 12, one of them has to be negative. Which one? Well, the bigger number gets to carry that middle sign. So this would be a positive 6 and a negative 2. Likewise here. Subtract to be 4, but the 4 is negative, so the 6 is negative. So that's how the basic unfoiling works. That should be pretty straightforward. Let's see if we can kick it up a notch or 3. What if the a is not equal to 1? This is a more difficult process. And what we have is, it's called the AC method. We're going to multiply, because it's cool, we're going to multiply A and C together and then list all the factor pairs of that and see which of those factor pairs combines to be the B, all right? So let's see if we can figure this out. This A times C equals 5 times 26. 5 times 26 is 130. Now what I'm going to do is list all the factor pairs of 130, the pairs of numbers that multiply to be 130. Like 1 times 130, 2 times 65, 5 times 26, 10 times 13, And those are all the pairs. And recognize that these could both be positive to multiply to be 130, or they could both be negative to multiply to be 130. And now what I need to do is look at each of these pairs and see if there's a pair of numbers that adds to be a negative 23. Kind of, yeah. If this were negative and this were negative, wouldn't a negative 10 times a negative 13 be a positive 130? And wouldn't a negative 10 plus a negative 13 add up to be a negative 23? Ah, sweet. So now what we do is we take this negative 23 and we split it up into a negative 10x and a negative 13x plus 26. I've taken the 23 and broke it into its two different parts. Now, I don't normally like the add the opposite, but in this case, you kind of have to do an add the opposite for some of these terms. So let me change this to add the opposite. And now what we're going to do is we're going to group these together. These right here are going to group together, and these are going to group together. And now you look to see each one of them separately. Is there anything in common with these two right here? Is there anything in common between the 5x squared and the minus 10x? Yeah, a 5x. And a 5x times what gives you a 5x squared? That would be an x. And a 5x times a what gives you a minus 10x? Minus 2. Plus, what's in common between these? A 13. I'm actually going to factor out a negative 13. Negative 13 times what gives you a negative 13x? X. Oops, wrong color. Sorry. And a negative 13 times what gives you a positive 26? A negative 2. And now, do you see that there is this x minus 2 that can be taken away from the 5x minus 13? Yeah, I'm going to factor out the x minus 2, and that's going to leave me the 5x minus 13. And that is this thing factored. Check your notes for that one right there, and also check the notes for the rest of them. But I think I am done with you for the day. Email me with questions.